Greetings to the respected faculty. I am Lasya Mandapati from CSC AI&ML B section. My roll number is 24951A6686. And today I'll be talking about the topic moving the OS or operating systems to the web. This idea comes from an IEEE article published in 2008, but it's still very relevant today. Normally, we think of OS as something installed on our computer, like Windows or Linux. But what if the OS itself could live online and you could just log into it from anywhere? That's what this talk is about. I'll explain what it means, how it works, its advantages, challenges, and what the future holds. So let's dive in. Let's start with some background. The OS is basically the foundation of your computer. It manages hardware, memory, storage, and apps. Traditionally, it always lived locally on your machine, but over the years, we saw apps move online. For example, instead of using installing Outlook, we use Gmail on the browser. Instead of Word, we use Google Docs, also on the browser. This has got people thinking, if apps and data could move to the cloud, why not the whole operating system? A web OS is basically exactly that. It's like an OS you can access through a browser from anywhere at any time. Of course, there's key differences. A traditional OS is tied to your hardware. It controls your CPU, RAM, and files locally. A web OS, on the other hand, runs on a remote server. You open your browser, log in, and see a desktop like interface. Your apps, files, and settings are all stored online. The upside is flexibility. You're no longer tied to a single machine like before. The downside is that it depends on internet connectivity. So, really, it's a trade off local control versus global accessibility. So, why are we even bothering with this? Well, there are seven strong reasons. First, accessibility. You can log in from any device and instantly get your personal desktop. Second, platform independence. It doesn't matter whether you're on a Windows, Mac OS, or Linux, or even a Unix, as long as you have a browser. Third, maintenance is far easier. Updates happen on the server side, not on your laptop. And finally, collaboration. Just like we share documents on Google Docs, a web OS could allow shared environments for group work. Basically, it makes computing more universal. A web OS has some unique features as well. It's browser based. You don't boot into it like Windows. You open it through browsers like Chrome, Firefox, or Safari. The client device is lightweight because the heavy work happens on the server. Apps are delivered as services, so you don't install them. And all your files live in the cloud, making them accessible from anywhere at any time. The main catch is internet dependency. If your connection is bad, your OS experience suffers. However, if your internet is good, your OS experience is far superior. Let us also discuss the system architecture of the web OS. Traditionally, the architecture has three parts. First, the client, a browser or thin device from where you're accessing the web OS. Second, the middleware, which handles the communication and security. And lastly, the third, the server, which hosts the OS, runs applications, and manages storage. Each user's environment is isolated using virtualization. So even though many people share the same server, it still feels like your own personal OS. This structure makes it scalable for millions of users. As you can see, the structure is defined in the picture here, which consists of three parts: the client, the middleware, and the server. Virtualization is what makes it possible. It's what makes the concept of WebOS possible because instead of directly exposing hardware, the server creates virtual CPUs, virtual memory, and virtual storage. This means the OS doesn't care what kind of device you're using. It just sees standardized resources. It also ensures isolation. So no one person's work doesn't interfere with another. Basically, virtualization gives you the feeling of a personal OS even though it's running on a shared infrastructure. Now, resource management. In a web OS, resources are managed at the server side. Storage is cloud based and can scale up or down. Processing power is allocated dynamically depending on your workload. Memory is virtualized, like we discussed before. And balancing, not only that, but memory is also separated between users. In addition to that, load balancing makes sure that servers don't get overloaded very easily. The benefit is that even low-ended devices can run heavy applications because the power comes from the cloud, not your machine. However, security is a major issue. First, authentication. You need strong logins, often multi-factor. Second, data privacy. Since your files aren't on your device anymore, encryption is a must. Third, there are network threats like hacking or denial of service attacks. And finally, trust. You're basically trusting someone else's server with your data. This is why security is seen as the biggest challenge for WebOS adoption. Well, practically, the biggest weakness of WebOS is the internet. If your internet is slow, the OS feels slow. If your internet is down, the OS is unstable. Bandwidth and latency play a huge role in user experience. Some hybrid solutions allow limited offline functionality, but it's not the same as a local OS. That's why quality of internet service is critical. If WebOS is going to work for businesses and regular users alike. There were actually some early attempts at this idea. iOS, spelled IEOS, was an open source web desktop initially launched in 2005. UOS, another browser based environment, offered, well, a browser based OS with an API for developers. Ghost called itself a global hosted OS. These were very innovative, but limited by the tech of the time. Browsers weren't powerful back then, internet speeds were low, and offline support was poor. Still, they proved that the concept was possible and directly inspired things like Chrome OS and Windows 365 today. And honestly, the advantages are clear. You can access your OS from anywhere. You don't need a powerful machine, just a browser. Updates and patches happen automatically, so maintenance is minimal. Collaboration is inbuilt since everything's online, and for providers, scaling to millions of users is easier with cloud resources. In short, WebOS makes computing more flexible, portable, and user friendly. But of course, there are still challenges. Internet dependencies means you're stuck without connectivity. Performance gaps make it hard for heavy tasks like video editing or gaming. Security risks are always present since data lives on someone else's server. And finally, user trust and adoption. Many people simply don't like giving up control of their OS. These are the reasons WebOS hasn't yet replaced traditional operating systems. The future is exciting though. The WebOS will integrate more with cloud platforms like AWS and Azure. We'll likely see hybrid models where some features run locally and others online. Security will improve with zero trust frameworks and better encryption. And as IoT grows, WebOS might become the universal layer connecting all devices. In fact, we're already seeing this in Chrome OS, AWS workspaces, and Windows 365 Cloud PC. So the future is definitely moving forward in that direction. To wrap up, moving the OS to the web started as a radical idea, but it's slowly becoming reality. Early concepts like iOS proved the concept. Today, Chrome OS and Windows 365 show how far it has come. The benefits, accessibility, independence, collaboration are huge. But challenges like security and connectivity still hold. One thing is clear, the boundary between local and cloud based computing is fading fast. In the future, we may not even notice where our OS lives. It'll just work anytime, anywhere. Thank you for listening to my talk. I hope you get I hope you've got a clear idea of what a web OS is, why it's important, and where it's heading. Thank you.